Hi everyone, welcome to the third class of SQL Server. Yesterday, what we talked about is that we talked about SQL Server, the different versions from where the journey started for SQL Server, what are the different features that are there in SQL Server, what are the different editions in SQL Server. Then we also talked about the different type of master databases that are there in SQL Server, right? So we talked about all those stuff yesterday. After that, in the end of the class, we also talked about files and filing, right? We just touched base with different concepts like we have the data file, we have the transaction log file. At the same time, we talked about how file groups are binding these files together, right? Today, we will start our journey focusing more on the files because that is one of the important stuff, not from the developer perspective, not from the BI developer perspective, but from the DBA perspective. And as we talked about that, we are going to cover everything about SQL Server. So that's how it makes uh, more important to cover those aspects as well. So let's talk about the file in details. And that detail is actually related with some other concepts as well. So today we are going to focus first of all on transaction log and data configuration options, right? Every SQL Server database has a transaction log that records all transactions and database modifications made by each transaction. The transaction log must be truncated on a regular basis to keep it from filling up. The transaction log should never be deleted or moved unless you fully understand the ramifications of doing this, right? So every database or every SQL Server database has a transaction log. We definitely talked about that yesterday. If you remember, we have the primary data file, we have the secondary data file, and then we have the log file. So the SQL Server actually records all that transaction that is happening inside the system in that log file. And whatever modifications you are doing, that also goes inside the log file with the timestamp. That means at what time what modification took place, so that in case of any failure, that log file can be used to recover the data. The transaction log must be truncated on a regular basis to keep it from filling up. This is what is suggested on the lower environment, because in a company when you work, there'll not be just one server, right? There'll be multiple servers. One server for the development environment, one server for the testing environment, then we'll have the UAT or the staging environment, and then in the end we'll have production. So this is how it is. Normally, when we are talking about truncating the transaction log, we are talking about the lower environment. Normally, you want truncate the transaction log file in the production environment. The transaction log should never be deleted or moved unless you understand the ramifications of doing that. Basically, what I want to say here is that you should not be deleting the transaction log file. That is a very important file, because if you delete the transaction log file, you won't be able to recover at a particular time in the SQL Server. Suppose that what you did is that you have the backup copy of the database. You restored the database using that backup. After that, you ran some of the DML statement. By DML statement, I mean insert, update, delete. And then after that, something happened in your system got crashed and all. In order to recover such a system, the only way is that use the transaction log file. And that's why you should not be deleting the transaction log file until you understand how important your data is and all of that, right? So as I said yesterday, now whether the transaction log is stored or not, that actually depends on something else, which is known as the recovery model. So that is what let's talk about. What is a recovery model? SQL Server backup and restore operations occur within the context of a recovery model of the database. Recovery models are designed to control transaction log maintenance. Three recovery models exist: simple, full, and bulk log. A database can be switched to another recovery model at any time. Basically, in SQL Server, we have three types of recovery model. One is a simple recovery model, second is the bulk log recovery model, and third is the full recovery model. As the name suggests, The full recovery model is the model in which everything that is happening inside the system will be logged. Normally the production DB and all, you keep it as a full recovery model. The simple recovery model is something where nothing is logged. That means any transaction log is not stored there. So that is the situation where you'll be using this for the development environment or maybe the testing environment as well. The bulk log recovery model is one of the recovery model in which actually what will happen is that only the bulk operation will not be logged. Anything other than the bulk operation will be logged in the bulk log recovery model. So in order for you to understand that, how do you know that particular database is in with recovery model? How can you know that? So you have to just go and click on the database, right? For example, I clicked on this database. I go to the properties. Inside once the property windows open, you will see lot of tabs here, right? There's the first one is the general tab, right? Which is having some information. Then comes the file tab, which has some information. Then comes the file group tab, and then the fourth one is the options. In the options tab, if you see the second thing, it's talking about the recovery model. And if you go and click on that drop down, you will see 3 recovery model there. As of now, I have kept my recovery model to be simple for this database. Why I have kept simple? Because if I keep it to be full, what will happen is that the log file will increase rapidly. Anything that I'll do on this database will be logged. And that's why the space, and I don't have that much space in my system. I don't want to log anything because this is just test data. And that's why it makes sense for me to keep it simple recovery model. But if this would have been a production system, I would have kept it to be full, right? If it would have been UAT, maybe I'll keep it like bulk log. So depending upon the type of system, I'll keep a particular recovery model, right? So now let's go back. Let's talk about each of these recovery models in detail. Then we'll come back again. So simple recovery model. As I said, no log backups. That means we'll have the data file, but we'll have the transaction log file, but it would be just empty. Nothing would be containing there. Automatically claims log space to keep space requirement is small. So one of the major pros or the benefits of the simple recovery model is that it will just keep it will not require a lot of spaces. That means you can do your things in the small spaces and all. Operations that require transaction log backups are not supported by simple recovery model. So any operation which would require transaction log backups are not supported by the similar. That means anything that will actually require the log backup, that means where you want to maintain the log and all, that will not support simple recovery model. Now, what is the work log exposure when we go for the simple recovery model? So changes since the most recent backup are unprotected. In the event of disaster, those changes must be redone. So this is what would happen in the case of the simple recovery model. That means any changes in the most recent backup are unprotected. That means like I was giving you the example that you did the backup, right, of a database. After that, you ran some DML queries and then your system got crashed. In such a situation, you won't be able to recover at that point in time in the case of simple recovery model. And you'll need to do those changes. So normally in the development environment, we do something which is not related to customer and all. So it's fine to have that loss. So if we understand that there can be such loss in case of disaster, then definitely we can go for the simple recovery model. Can we recover to a point in time using simple recovery model? Definitely not. Why? Because we are not storing the logs, right? Logs, definitely the transaction logs are required to recover in a point in time. And that is not possible with the simple recovery model. If anyone has any question, you can stop me at that point and you can ask question. I'm
Sorry,
just
sorry. Can
assuming.
you
Yeah,
say, can you repeat a simple recovery model again once? Sorry.
sure, no problem. So let's understand it by example now, because we have already understood tried different way. Let's try with different way now. So we are talking about the single recovery mode, right? Suppose that you created a database, a DB named batch 266, right? This is the DB you created. Now, after creating the DB, what you did is that you ran some insert statement at 710. Okay. Then you ran some update statement. By 710, I mean a time. Like at this time you ran, maybe at around 7:15. Sorry, 7:15. And then again after that you ran some insert statement at 7:12, 7:18, and then maybe some delete statement at 7:21 or 20, and then your system got crashed at 7:22, right? Now we have selected the simple recovery model. We had this database, right? When we created the database, we also took the backup of database, right? So we have the backup at this point of time, maybe at 7, 8. So we took the backup of the DB at this time. After that, we ran all these 4 statements, and then our system got crashed at 7:22. Now, what I want to do, I want to recover the DB, and at which point in time, 7:22. So I want to make sure that the DB is in the same state at it was at 7:22. If we have the simple recovery model, this is not possible, because what is happening in case of simple recovery model, SQL Server is not maintaining track of all these statements that are running, because the transaction logs are not getting updated with all these statements. So we can recover only till 7:8. This is what would happen in case of the simple recovery model, because the transaction log is not getting updated with all these statements and timestamps. So that's why you can't recover. Now suppose that we had not the simple recovery model, but we had the full recovery model. In that case, what would happen? So we have definitely, we can now in case of simple recovery model also, we can actually, because we have the backup, we can restore till 7:8 in case of simple recovery model as well. So backup, because we have taken the physical backup of the DB, so definitely that can help us to restore at any point of time. So at till 7:8 it's fine. We can, even if we use simple, bulk logged or full, we can recover to this point in time. So through that backup, we can recover until 7:8. In case of full recovery model, suppose that our database was in full recovery model, in case it is maintaining log of everything, then after this, I can just put the transaction log file there, and then it will, because it has the what statement was executed and at what time, it will execute the same statement on the DB again with the timestamp. So the timestamp is very important, because that will decide that in what order, what should be the first statement that should be executed, then the second, then the third, then fourth. So it will execute everything, and then it will make us to this point. That means 7:22. And you have again the same DB ready again, because we chose the full recovery mode. Is it clear now?
Yes.
Okay. Now, the third recovery model, let me explain that one again. So suppose that we had all this and we had kept bulk log recovery model. So what is the difference in the bulk log recovery model? Suppose that at this point in time, at around 7:16, I ran another statement, which is a bulk insert statement. So bulk statement are a statement which are maybe inserting maybe 10 million records. So if we are trying to insert a lot of records, trying to delete a lot of records at the same time, that is known as the bulk operation. So sometimes we run bulk operation as well, right? So in terms, so we have this third recovery model, bulk log recovery model, which is actually made to give you a compensation between the simple app and the full recovery model. In case of simple recovery model, you can save a lot of space in your system, right? Because all the operations will not be logged. In case of full recovery model, though you can recover to any point in time, but the issue here is that uh, the problem here is that it will require a lot of space. So definitely you should not keep your development environment and all where you don't have the customer data to be the full recovery model, because again it will just fill up everything and it will fill up the log space and all. Now the third one, which is the bulk recovery model, it will actually store all these insert, update, delete operations, but any bulk operation which is running, it will skip that operation. So you won't be able to recover the bulk operation in case of you are having the bulk log recovery model. But again, we don't run a lot of bulk operations inside the database. So definitely at some point in time, you can definitely recover to a point in time, but that is not true. If someone asks, can you recover to a point in time in case of bulk log recovery model? Definitely you can say no, because again, you don't know whether any bulk insert or update operations were there in the DB or not. So anything like this where you are in at bulk, you are inserting or deleting, definitely you can't recover that statement. Apart from that, if you can recover every statement. That means if I want to recover the DB at this state, definitely I can't do this with bulk log recovery model in this scenario. But suppose that if we don't have this statement, in that case, I can definitely recover to this point in time. So it depends, right? So that is why we have the bulk log recovery model. So if anyone asks, what is the recovery model you will choose for production? So in that case, you will say the full recovery model, because everything would be logged. And in the production, you have the sensitive data. You want all the data to be there, right? So that's why you will select it like full recovery model. For the development environment, which recovery model you should choose? You should choose the simple recovery model. For the staging and QA, maybe you can choose the bulk log recovery model, right? So that's how it is. Now let's read more about all these recovery models. So the full recovery model, it would require the log backup. No work is lost due to a lost or damaged data file. Can recover to an arbitrary point in time. So that means we can recover to any point in time using the full recovery model. Is there any work log exposure with the full recovery model? Normally there would be no work log exposure. Can we recover to a point in time? Definitely we can recover to a specific point in time, assuming that your backups are complete up to that point in time. So this is what would happen in case of the full recovery model. Next is the bulk log recovery model. It would require the bulk log backups and adjacent of the full recovery model that permits high performance bulk copy operation. Reduces log space usage by using minimal logging for most bulk operations. So as I said here, so definitely the bulk operation would be minimally logged or not logged, but other than that, everything would be logged. So that is what would happen in the bulk log recovery model. Is there a work log exposure? If a log is damaged or bulk log operation occurs is the most recent backups, changes is the last backup must be redone. So as I said, in case you had some bulk operations, then in case In that case, you won't be able to recover to a point in time in case of bulk log recovery model. Otherwise, if there has been no bulk operation, then definitely you can recover to a point in time. So to answer to whether we can recover to a point in time, can recover to the end of any backup, point in time recovery is not supported, because again, we are not storing the details of the bulk operation. So that's why the point in time recovery is not supported in case of the bulk log operator. Now, how do you take the backup of a database? We are talking a lot about backup, restore and all, but how do we do that? That is another important thing that we like to learn about, right? How do you delete a database which is there in the system, right? So let's first of all delete a database. I have this database AdventureWorks 2019, right? I just want to delete this database. I'll right click on this, I'll click on delete. This is how you can delete a database. I just click on OK. Now my database is deleted, right? I don't have that database now anymore. AdventureWorks database is the database that we'll use for most of our queries and all, because it has a lot of useful data, right? So we want to have that data. How to get that database is another story. Let me tell you that as well. Open any browser in your system, right? And search for AdventureWorks database. The first link, which is the Microsoft link, you have to just open that database link and you will see a lot of databases here. These are the backup files of all these databases. Anything with the .bak, that is a BAK is a backup file. You just need to install all this. Just right click. You can see that this is coming up, right? Then again, I'll take the data warehouse as well. I'll take this 2017 as well and 2017 DW. There are two type of databases. There are two type of normally there are two type of environments in SQL Server. One is the OLTP node, and second is the OLAP. OLTP means online transaction processing, and this means online analytical processing. What is the difference here? So most of you would be purchasing through any online shopping system like maybe Amazon, right? So any database which is actually linked with the front end of that system, right? That means the front end so definitely whenever you open Amazon.com or anything like that, that is the front end application. To that front end application, a database is always connected, because a database is the place where you store the data and all, right? So any database which is associated with the front end application, that is the that is a online transaction processing database. Now, any database which is actually associated with the reporting, right? And it is not associated with the real-time application, that is known as the OLAP, that means online analytical processing. So that's why we have two type of system. One is the OLTP and OLAP. When I talk about OLTP, we are talking about that databases which is normalized, which is having the which is connected to the front end application. And when we talk about OLAP, that means we are talking about data warehouses. We are talking about the reporting system, the databases which is connected to the Power BI report, or the databases to which you migrate the data from the OLTP system using SSIS packages. The databases where you have the fact and the sorry, where we have the star schema and the snowflake schema. We'll talk about that later. Right now we are focusing mostly on OLTP system, right? Now we have just downloaded few databases, right? How to use that database, how to recover using that database. So I can just copy this four databases, right? And then I can just go to the place where I've installed my SQL Server. So how do I know that? So I can just click on this any of the database, go to properties. Inside the property, go to files. In the file, what you will see is that there's a path, C program files, Microsoft SQL Server, then MS SQL 15.ms SQL Server. This is where my SQL Server is installed. So I'll just go to that file, C program files, then I'll go to Microsoft SQL Server, right? In that, this one, and here at any place, I can just paste those 4 databases that I've just, right? So I have these 4 databases here now at this path. Now I want to so I have just the backup copy of this. Now this is known as the backup copy of the database. Through this copy, I can restore any database. So I can click on databases and click on restore database. Once I go on restore, I have to actually select from where to restore. So I can click on device. Device means the local hard drive somewhere, and click on file, click on add. And here I have to go to that location where I've kept the backup file. So here I've copied and pasted all the backup file. So maybe I want to pick up this first. I will click on that. I click on OK. I'll again click on OK and again click on OK. So you can see that I got this message, database AdventureWorks 2019 restored successfully. I can click on OK, and as you can see that we have this database here. In the same way, if I want to do for other database, I'll again go on databases, restore database, click on device, click on these 3 dots, click on add, again click on this one. Here I'll select the maybe this one, DW 2019. Click on OK, click on OK, and click on OK. Now this database is also restored. So in this way, you can actually restore all these different databases, the 4 database. You have to first search for it. But any of if we are not able to do, I'll also send you the link and all from where you can download and all those stuffs, right? So the other thing that I'm going to send you today, right, is about the installation, how to install the SQL Server. That is the other thing that you need to do, right? So this all different things I'll send you once I'll have the email ID of everyone. So I'm waiting for that. Once I have the email ID, I'll send all these details to everyone, and through that you can install the SQL Server. And if in that, though it's very, it's very straightforward, but in that case you face any issues, you can come back to me and you can ask questions that hey Anup, I'm facing this problem and that problem. Will definitely resolve those problems as well. Now with that, let's move on to the next step, which is about creating or talking again about some of the things that happens inside the SQL Server. And then after that, we'll just move forward and we'll create our first database in SQL Server. So as of now, I'll just restrict today's class to the point where we'll talk about the SQL overview, that what happens is when you run a query and all those things. In the next class, once you have the SQL Server installed, then after that, I'll start with creating the database, how to create a database, which command you use to create the database. And from there, we'll start our query journey as well, right? So let's first talk about what is a SQL. Why do we call this language? Why this language is very important and all. So SQL means structured query language. The structured is the most important piece here. When we talk about unstructured and structured, then we can also differentiate, okay, what is something which is we call as structured DB, what is something which is so SQL is a type of DB where you store the structured data. That means you have the tables in which you store the data, and those tables, they have columns defined, and then you have some data in each of these columns. In the unstructured language, you won't have these columns and all defined. It can take any format. So SQL is an ANSI standard. It is a language of databases for storing, manipulating, and retrieving data. So if you want to store the data, if you want to retrieve the data, if you want to do some changes in the data, that is where you'd use this language. And why do you use a SQL? That is the other thing. So it allows users to access data in RDBMS. If you want to access the data, you'd use SQL. If you want to describe the data, you'd use SQL. If you want to user to define or manipulate the data, you'd use SQL. It allows you to embed in other languages as well. That means you can use SQL with C Sharp, Java, and any other languages as well, right? And then it also allows user to create and drop databases, tables, etc. So these are the different things that you can do in SQL, and this is what we are going to learn in the future with the practical examples and all, right? Though this looks like just 5 statement word, this is very vast. As part of that, let's also understand what happens when you write a query, right? What happens is that, for example, I'll just write a query here. I'll just select this database. As of now, I have not told you how to select a database, so just ignore that for now. We'll cover those parts from the basics again when we start with the query. As of now, I'm just trying to show you something else. So we have this schema and we have this table inside this. When I run on execute, I get the result here, right? You can see that I ran this query and I got the result. But this is not it. Actually, when you run the query in internally, SQL or Microsoft does a lot of things inside. So in this SSMS, it's not like just that you ran the query and you got the result. There are a lot of intermediate processes inside this, and we are going to talk about that using this diagram now. So you ran the SQL query, it goes to the query language processor, which has two things. One is the parser and second is the optimizer. So like if I ran this query, but if I missed the star here, right? So has every language has a pattern defined. It has the syntax and all, right? Whenever you run a query, the first thing that is actually looked into whether the syntax is correct or not. For example, if I try to run or execute this query, I'll get the error. Why I got the error here? Because whenever we run the query, the first thing that it goes to is the parser. The thing that parser does is that it checks whether everything is syntactically correct or not. If it is not correct, then it will again come back to the user and it will say, hey, this is not correct. This is the user, this is the problem with your query, right? And then you have to correct your query. So likewise, I got the message here that there is an incorrect syntax near the keyword from. So I'll just add that select star now. And now I'll run this query again. This will work totally fine because it moved to the next step now. So as I said, there are two terms in the query language processor. One is the parser. The, the work of parser is to check whether the query is syntactically correct or not. Once that is done, it goes to the optimizer. The purpose of the optimizer is to actually check what is the most efficient way of executing this query. What is the least costly way of executing this query? That is what the optimizer would do. What does it mean? It means that whenever we run a query, SQL Server or Microsoft has at least 10 different methods to get that query executed, or 10 different operators to get that query executed. And SQL Server will choose a particular operator on the basis of the cost and all. So it will actually check, for example, just think like that. If you have to go from your place to your friend's place, who is living around 200 miles from from your place, right? What is the way you can go from you to your hotel? You will use the map, right? You will maybe start the Google map and you will see, okay, and then Google map would actually show you, okay, these are the different ways through which you can reach to your friend's house. And then it also shows that, okay, this route is 2 minutes slower, this route is 4 minutes slower, and all of that it shows. Though it shows you multiple ways, but it will also show you this is the way which it has selected for you because this is the most faster route, right? This is what happens. In the same way, when you run the query, the optimizer, the thing that optimizer does is that it will actually select the best way to execute that query, the best cost effective way, right? So that is the purpose of optimizer. Once it has selected that, then it goes to the DBMS engine. The DBMS engine actually has two things. One is the file manager, second is the transaction manager. File manager is actually, it manages the file, the data file that we have. It will store that information, or it will take the information from that file system or the data file. And the transaction manager is all about the transaction log. So it will also put that information that this is the query that we are trying to run, whether it's a DDL, DML query, like that. Based on that, it will put all those. So this is where we do the management of files. That means uh, whatever statement we are executing, let's log that statement in the file manager or in the data file and in the transaction log file. Once that is done, then it will come to the physical database. Physical database means the place where actually the database or the data is stored, right? So it will come to that place and it will store the data. Let me show you one thing by example here. So as I created the backup here, let's see the size of this backup right now and when it was last updated. You can see that last modified at 724. This is a BAK file and this is the size of this 212088 KB. Let me let me just take a screenshot of this. Right, I've taken a screenshot of this. Now let me do one thing. In this database, I'll do some changes. Create table, customer, customer ID, and name. Don't bother about how I'm writing the queries and all. We are going to learn in from the very basics of all this. So don't bother it about it. Just see what I'm showing you right now. Let's focus on that only right now. So I created this customer table. Let's see if any changes happened inside this database or not. As you can see that this there we don't have any changes, right? Now let's go to the data folder of this this SQL Server, right? So in the data folder, what you'll see is that you will see all the different databases that you have, right? So in the same way, you will see that you have this AdventureWorks database as well here, right? And just now at 7:39 a.m., I made some changes. You can see that that log file changed at 7:39. This is the transaction log file, and it changed. And if you see the data file, the size of this is different than what we had in the log file, right? Or in the backup file. So if I make more changes here, for example, suppose that I create another table here, employee, ID, name. I again created this table and now I created at 740, right? Let me go and let me see whether it got modified or not. So again, this is coming like this. Now this log file, if you see, this is coming like 739 only. What is the reason for that? Why this didn't get modified in this instance when we created? Anyone can give me that, because we already covered that as part of this class today. Can anybody tell me why this didn't get modified?
It's in simple recovery.
That's correct. So as Chris said, because we have stored this database in a simple recovery model, that's why whatever we are doing here, everything is not getting logged. So in order to make sure that we are logging everything in the transaction log file, whatever changes we are doing, then we have to change it to full recovery model. Then after that, whatever queries you will run, you will see that this will get modified, this will keep on increasing and all, right? So if you want to do that, you can just try all these things once you have installed the SQL Server and all, right? So I'll leave on you to do that practice on your own. Once you have everything installed, you have the databases installed. So that would be maybe the first assignment for you. But as of now, we were talking about the query processing in SQL, right? So as part of the query processing, when you run the query, first of all, it goes to the parser, which will check the syntax and all. Then it will go to the optimizer, which will optimize the query. It will say, check, okay, what is the best way to execute the query, most cost efficient method to execute the query. Once that is done, it will go to the VMS engine, which has the file manager and the transaction manager. It will store that things in the file and all. Then it will go to the physical database. So this is where we have the data file stored. So this is what you can say as the physical database, right? So once it goes there, it will bring on the data from there. And once it brings on the data from there, then then it will go back to the query, and in the result window, you see this result, right? So whatever result that you are seeing instantly, SQL Server is actually doing a lot of things inside to give you this result, right? So this is how a query runs, right? Though you see that everything we are getting in just 0 seconds, in some microseconds and all, but actually there are a lot of processes involved in running a query. I hope this is clear to everyone. Now the next part of this is talking about the different type of commands. Though we have not talked about this, but again I was using this term DDL, DML, right? So we have four types of commands in SQL Server. All the commands are actually divided into four categories. The first one is the DDL command. Second is the DML command. Third is the DCL command, and fourth is the DQL command. Right? These are the four different type of commands we have in SQL. Let's talk about the first one, which is the DDL command. DDL means data definition language. It is used to define the data and its structure. Example includes create, alter, and drop. So basically in the using the DDL command, what we do is that we use the data definition language command, something through which you can define the data. So that is known as the DDL command. So for example, we can create a table, right? Using the create table statement. That is a DDL command. We can alter the table using the alter statement. That is also a DDL command. We can also drop a table using the drop statement. That is a DDL command. So all of this which actually change the definition of the any object, that is known as the DDL command, right? Next is the DML command. What comes inside the DML command? DML means data manipulation. So through which you manipulate the data. As of now, through the DDL, what we were doing is that we were changing in the data itself, or we were defining the data or the object, right? So through the create table statement, you create the table, right? To alter, you alter the table. To drop, you drop the table. So you are changing things in the structure, right? So those commands are known as the DDL command. In the DML command, you don't do anything about the structure. You always talk about the data. That means you insert the data, you update the data, you delete the data. So whenever you manipulate the data, that is known as the DML command, or the data manipulation language command. Next comes the DCL command. DCL means data control language. So this always talks about security and privilege and all. So it is used to control the data. So through the command through which you actually give access to data or take access from the data, that would be known as the DCL command. right? So for example, the grant command and the revoke. Through grant, you give permissions to a user to a particular data set. Through revoke, you take out the permission for a particular user on a data set, right? So anything which is actually controlling the access of data, that is known as the DCL command. The last one and not the least one is the DQL command, which you use the most. The select statement is actually the DQL language command. That means the data query language. Anything through which you can query the data, that is known as the DQL command, right? So let's again repeat all this that we have. The first one, we have the DDL. Through DDL, you define the data. That's why you are saying it as a data definition language. So defining the data means creating the table, dropping the table. Through that, you are doing the structural changes. So that is a DDL command. Second one is the DML command. Anything through which you are manipulating the data. That means either you are inserting in the table, you are deleting from the table, you are also updating data in the table. So that is all the DML command. The third one is about access control. That means anyway you are giving the permission to the data, right? You are taking out the permission to the revoke, you are granting the permission to the grant command, that is the DCL command. And last one is the DQL command, which is the data query language command. It is used to retrieve the data. And the select statement is one of the best example of using the DQL command. So this is all about the data query language. We'll just now the next step of for us would be to create the database and all, which you will be doing in the next class. Once you have the SQL Server installed and all, after that we'll be going and we'll be creating the database so that you can also follow along after the end of the class, right? So that is all I wanted to share for today.